Hello, ladies and gentlemen, and welcome back to this fourth and final day of the FT's Future of the Car Summit. My name is Joe Miller. I'm the Financial Times correspondent in Frankfurt. Now, if you've been watching until now, you'll know that today is dedicated to batteries, all things batteries and battery technology. And that is precisely what this panel is about. It's entitled The Rate of Progress on Solid-State Batteries. No, there's been a lot of excitement in recent months and indeed in recent weeks on technological advances with current lithium-ion batteries, but the current generation of car batteries come with a load of trade-offs. For a start, charging time. We're all familiar with efforts to reduce those, but also in terms of energy efficiency and even in terms of safety. And that is why the industry has been holding out hope for solid-state batteries. These are really the holy grail, as we will talk about in the coming panel. But the big question is, when will they be ready to be commercialized? And that's precisely what we will be discussing. So please welcome my panel. We have Stephen Gifford, who is the chief economist at the Faraday Institution. We have Mark Newman, who's the founder and CEO of Electric Revolution Insights. We have Celina Mikolajczak, who's Chief Manufacturing Officer at QuantumScape. And we have joining us again, Waseem Ashraf Qureshi from WRL Technologies. Welcome all. Thank you for being with us today. So I thought we would kick off with the high-level question that this panel poses, which is the rate of progress on solid-state batteries. And the question really is, when will solid-state batteries, this great big white hope for the battery industry, when will it make it onto the roads? When will we see this in cars? When will it become a viable, both economically and technically viable product? Why don't we start with you, Stephen? Looking at this as a chief economist, where do you see the inflection point, the point at which we start seeing this technology rolled out?
Thanks a lot. Yes. Well, I think it's going to be a series of inflection points rather than a point in time. So we're on a journey, and we've been on the journey already for a number of years. I think already we're in the stage where there's quite a lot of initial testing, prototyping, and pilots from now over the next few years. But I think, and some companies are already under production. But I think we'll see most entry points of production around 2025, 2026. Depending on which type of solid-state technology companies are interested in and looking at. And then mass production from around 2030 and the early 2030s, growing the market then. But I don't think we'll really see mass market in terms of the consumer until about 2035, when the solid-state battery costs are likely to be very competitive with lithium-ion battery costs. Already, lithium has got a lot of manufacturing efficiencies in over the past few decades, been going on for quite some time. So solid state has a lot of time to catch up. So I think we'll also see a segmentation of the market. In the first sense, it's a usual story of technological disruption. New products, more expensive products really go into a niche or premium product line. So if you could think about the automotive market, it's going to be at the higher end initially, solid state. So as it's more expensive, into sports utility, into the larger vehicles, into luxury and niche models. So premium, because of the extra costs, consumers are willing to pay for those extra products that you mentioned, extra performance, so extra safety, extra faster charging time, enhanced performance, for example. So all those things the consumer is initially willing to pay for. And then over time, you'll go into more mass market as the solid state technology battery costs come down.
And we'll talk a little bit more about costs, I'm sure, during this discussion. Celina, you at QuantumScape are at the forefront of trying to get this technology to a stage where it can be commercialized. I suppose the question everyone wants to know, wants an answer to, is what are the hurdles to getting to that commercialization? It seems that the technology itself, there are very few people out there who dispute that this would be, a leap forward in terms of technology, but their question really, and correct me if I'm wrong, is on commercialization. Is that correct?
Sure. So this is a big jump in technology, right? It's people have kind of tried to make batteries with lithium metal anodes that are drop-in to conventional lithium-ion cell making. Um, they have not had traditionally success with that, and at QuantumScape we don't think that's actually a real path to go forward. We're really looking at a different architecture. That doesn't mean that we can't leverage a lot of what the industry already uses to make batteries. There's big chunks of our production process which are very much like conventional lithium ion, but there's also pieces of it that are unique to our technology. And what does that mean? Well, it means we do have to develop those tools and uh, put them in place and scale them and do all the cost down measures that we talk about. But at the same time, we think that the performance value is so substantial that uh, you've got a big demand for it, even if it's going to be initially at a higher cost, right? Um, and then when we look at it, with a solid state battery, if you get rid of the graphitic anode, your price comes down, and it doesn't come down just because of manufacturing efficiency. It comes down fundamentally because you've got less,
Raw
fewer
material.
materials
Yeah.
that you actually have to put in the cell. So, we think we know that there's the economics have to be right. We also know that there's a fair bit of work in developing the manufacturing tools, but we think these are tractable problems, and uh, we're aiming for something a little sooner than 2030. We're targeting 24, 25.
Right. Okay. So we've upped the ambition a little bit there. Mark, I know that you have been watching this industry for many, many years, and I think one of the questions that people have when it comes to solid-state batteries is, haven't we already solved the problem with batteries when it comes to EVs? We basically have batteries out there now that can give you the range of a full, petrol or diesel tank. Battery costs are coming down, although recently, of course, there's been a spike because of events around the world. But a lot of people look at this and say, do we need the next technology, or do we just have a sufficient solution right now? What would be your take on that?
Yeah, I think it's a good question, and I think that that's generally true. That today's batteries are pretty much good enough for many use cases of EVs. But I still also think that there's always going to be a demand for improving technology, right? There's always going to be a demand for high energy density, high energy density in the long term. Although some of these solutions like solid state might actually, or very likely, are going to be much more expensive at first due to the huge manufacturing challenges. If it is high energy density, theoretically, it means less material for each unit of energy. So therefore, theoretically, it should be cheaper per mile driven. So I think it's still longer term. It's a good direction to be focusing on these technologies that allow for and drive high energy density in the batteries, because it will allow longer range. It will, in the very long term, allow cheaper batteries, maybe not in the next decade or so, but very long term, they should be cheaper. And it also enables other things such as longer distance trucking to move to electric, and even things like eVTOLs, flying cars, electric aviation, etc. Because for those applications, energy density really is not good enough at all, and so you do need the higher energy density. So all of these things, solid state is just it's one of those enablers. Really, I think to me the key cool technology is the lithium metal anode, and you can enable that through solid state, like what QuantumScape is doing, or you could enable it through some other ways, such as what SES is doing, which is more of a liquid-based approach. I think both of those will allow significant increases in energy density, which is longer-term direction.
Waseem, we heard from you earlier that you think you're just a few years away from getting your technology into cars and out there into the market. What, however, are the bottlenecks, or I should say the hurdles, when it comes to commercializing this technology? What's stopping everyone from going even faster?
Okay, yeah. So, this- Joe, let me explain you the whole journey of any technology. But when it comes starting from invention to the commercialization, you first of all you invent the technology, then you develop a product based on that technology, and then you mature that technology on different sample sizes. Testings are done, certifications are done, product technology gets validated, and after that, you go for scale of production and commercialization. All of these things need a lot of time, but automobile industry has been, very strange and very fast, I should say, in all of these phases. Just imagine that when the gas cars came in only 6 years, there were gas stations all over the world because the need pushed everything. And today, when we are in 2022, it's just the development of technology. And we have an added advantage that we started stationary batteries back in 2015. And we did all of this process with conventional supercapacitors. We launched the product in 2018, and all of this has been done, and we are ahead of the world on this. So we are very hopeful. We are launching our product this June 2022, and initially we are starting from performance cars because supercapacitors is our main product, and that is the need, the type of energy and power these vehicles need. Supercapacitors can store and deliver, and we have disruption in all of these things as well. The cost, we are not using 100% graphene. We have material mixed in it, like tantalum and some other special materials, which is reducing the cost, and we are very hopeful that we'll be able to compete lithium ion, conventional lithium LFP batteries with our supercapacitors. And one more thing, which is added advantage with our development, is that we have completely embedded the electronics inside the cell itself. So there is no need of any external BMS or any external electronics. You just add on cells and you use it. So we have prepared a couple of products which we are planning to introduce coming June.
I should have mentioned, thank you, Waseem. I should have mentioned earlier that, of course, you can all put your questions to our distinguished panel using the chat box that's on the bottom right-hand side of your screen, I believe, and I will put as many of them to our panel as is possible in the time allowed. Stephen, I wondered, with your overview of this industry, one of the things that is striking is that the big players, so to speak, have put all of their weight behind lithium-ion batteries for the meantime, and that is where both the industry's money is going, but also government money is going. And while everyone is interested in solid-state batteries, it's seen as sort of this kind of far-off thing. Do you think that this investment is a problem, that there's not enough going from lithium ion but into the solid state world, that there's going to be just such a volume of investment into our current generation of batteries that there just won't be enough momentum on solid state?
Well, I think it's a balance, really. So lithium has been around for some time, and all this investment is about marginal improvements, incremental improvements, and at some stage the performance of lithium batteries will reach a theoretical limit. And that's where the advantage of solid state will come in, because the limits, depending on what type of technology you have within the solid state ecosystem, can enhance performance and safety above lithium ion. So there is the potential there, a longer term potential for solid state. So it's absolutely not as much research going in, but that's because the market is smaller. at the moment. I mean, it's a very, very small niche market, but as it grows, more and more research will pile into the sector. It's a long-term game. It's high risk, but it's potentially very high reward because it could potentially displace all of lithium batteries used in EVs. So, I mean, there are a number of challenges around costs which link to the level of investment, level of R&D. Costs. You need to get economies of scale in the manufacturing process. To some extent, trying to keep it as similar to the lithium production process as possible, because then you can draw on the elements and enhance the efficiencies already there. But there will be new parts as well that are needed. As one of our speakers said earlier, there's parts of the manufacturing costs that will be eliminated from solid state because of you don't need a liquid electrolyte, you have a solid electrolyte, so you don't need the separators, for example. And there are other parts as well which will reduce the cost. So I think overall, over the long term, it's where the research is going to be and where the investment will be. At the moment, that's not there yet, but that's not a surprise because the market is so much smaller.
Interesting that Stephen there says that we're not quite there yet with the investment. Celina, I know that at QuantumScape, you've had interest from lots of OEMs, and I dare say are doing okay. The question, though, is really whether the industry as a whole, the solid state industry as a whole, is getting enough investment, and whether you think there's enough R&D out there to really propel this forward, because it's kind of a tide that lifts all boats, isn't it? If there's enough interest and enough momentum. So when you look around the space generally, not just at QuantumScape, do you think that there is enough momentum?
Yeah, I think actually there is a lot of great research being done all around the world, and there's a lot of money that's gone into R&D for cells and batteries. In the United States, we tend to see that in academic research at the government labs. Overseas, the major battery companies, they are selling conventional lithium-ion cells, but by no means are they not doing the research for solid-state batteries. These guys have, huge materials and cell development organizations. They tend to be pretty quiet about what they're doing until they've got a product that they're bringing to market. So, I wouldn't say that they're not looking at it. I think they are very actively looking at it. I think there's a ton of R&D. Where I see, the difficulties for commercialization and going forward, I think we have a lot of great tech out there. We run into problems of how fast can you build it up? Putting together a pilot line for a cell manufacturing, putting together an entire cell manufacturing line, these are capitally intensive things to do. The investment is kind of at a much bigger scale than most people expect. And that becomes a bit daunting. And people have to realize that you're not going to make, you're not going to move the needle with a $10 million investment. You're going to be orders of magnitude bigger to get to scale. So that's one of the things. The other thing that we run into is we look very much at supply chain, and not just supply chain for raw materials, which is a big piece of it. And right now with a conventional lithium-ion cell, more than 50% of the cost of the cell is tied up in its BOM, right? In the raw materials that it takes to produce that cell, like much more. So, if you're going to bring that cost down, you have to reduce the BOM, right? You have to take things out or make them easier to manufacture. So we see that challenge, but we also see the challenge in simply buying the equipment to make cells and to scale. Conventional equipment makers are sold out of new equipment, or they'll tell you the lead times for, if you want to buy a coater to make cathode, lead times run 18 months. If you want to buy the equipment to run a dry room, just the equipment to run a dry room here, we're not talking something, fancy about the cell, you're looking at a year lead time before that piece of equipment will land in your facility. And that's kind of happening all up and down the industry. So where I think a lot of investment is needed is in the supply chain for the materials and the equipment to make cells.
It's interesting. We'll come on to the lead times in a moment with you, Waseem. But Mark, Celina was mentioning there that some of the manufacturers are quite quietly looking into solid state, and that's certainly been my experience. They don't really want to talk about it, but they are behind the scenes quite interested. What's your assessment of where the industry actually is, whether they are taking this seriously and are devoting serious resources to it?
Yeah, I think this is one of the challenges we have looking at this outside the big companies. Is a lot of these smaller companies or startups. Maybe it's not small. It's not a startup now. QuantumScape is public, and some of these companies are actually quite large now. But they are still the QuantumScape, SES of the world. They are still the challengers, right? These companies tend to speak more about what they're doing because this next generation technology is the main thing that they're working on, the disruptive technology to displace lithium ion. But the incumbents, which are the CATL, LG, Samsung's, Panasonics of the world, they don't talk quite as much about what they're working on inside, but they are all working on these technologies, be it solid state, various different lithium metal anodes, be it solid state or semi-solid or liquid versions of that. Silicon anodes is another way to boost energy density, and other things like lithium sulfur, which LG has been talking about quite a lot recently. So they're all working on something, and it's there's no, I can't summarize quickly what everyone's doing. I can't say I'm an expert on each individual company, but they're all making, and they've all made some progress in some of those areas. And I think Samsung, for example, has talked about their solid state. LG, I mentioned, has talked about lithium sulfur, just as an example. Oh, and I should mention CATL has been talking about their sodium ion, right? So these are all different new next gen battery technologies that, except for the sodium ion, are helping to boost energy density for longer range. But I still also think, though, despite these incumbents being a bit of a potential threat, that they might actually have something else that they're hiding. I still think, though, that there's a good chance that some of these challengers are going to be the ones that come up with something that is disruptive, that does displace these incumbents, because you can't guarantee that these big companies are going to be the ones to invent it. It's actually much more likely that it comes outside. So I do think the opportunities here are huge. I think that's why these companies have been doing so well. Some of these startups going public recently, because there is so much interest. The price of success is, the prize, I should say, of success is huge. And I think, that is going to be realized over the next 10 years.
Yeah, certainly the view the market is taking, that the challengers have the best shot at getting there. Waseem, as one of the challengers, we heard from Celina there that there are some quite big restrictions out there when it comes to lead times for equipment and supply chain, the bottlenecks as well. Your ambitions seem very bold given the environment when it comes to equipment and etc. Are you not worried about that? Do you think that the industry will just catch up? What's your view on that?
Yeah. So first, let me tell you that we are primarily an R&D company. So not only we invented the technology, we worked on the development of the manufacturing techniques and machines for our own products. This is the reason that this factory where we are sitting here, we are doing 80% of our all processes in-house, which we tend to do by 90% by the end of this year. And all of those machines, equipment, and platform codes, everything has been designed, developed in-house. So we didn't have this bottleneck of getting delays in coating machines and all those things. We do our own, and frankly speaking, solid state has much simpler processes than a conventional lithium-ion battery or any chemical batteries. It has much simpler and easier processes, and they are very fast and quick. Yes, you really need to work on scale of production, supply chain for the raw material, and this is the challenge every industry have it. And I think with our experience of last 9 years, we are very confident that we can manage it. That is the reason we are launching our product. On top of it, I would like to add one more thing that discussion on range. Actually, this is not the bottleneck. The success of battery technology is actually success of electric vehicles, because every EV is carrying 80% battery in it in terms of cost or in terms of weight or volume, whatever it is. So the point is that the battery should be the technology of the battery should be good enough to support and to good enough to replace the conventional gas vehicle. We don't fill in fuel in our cars overnight and optimize our trip for 200, 300, 400, 700 kilometers. We go to a gas station, we fill gas. When we get low in gas, we find another gas station. That's how the mobility works, and that's how everybody is used to drive a car. So now we are trying to change this trend, which is not accepted. Changes are not accepted in society, right? So we need to develop a technology that should work the same way. And I'm sure that I'm not talking about solid state only. The new modern technologies on battery will be able to replace existing use of conventional vehicles. That is what the world is looking for.
This sort of smoother transition. On that subject, we've actually got a question that's come in here, and feel free, any of you can jump in and answer this. If not, I will pick on someone randomly. But the question is, does solid state tech give more credence to battery swap models, given how much longer than vehicle life they are likely to last? And I suppose the real question is there whether it opens up an entirely new business model when it comes to batteries, where batteries are kind of separate to the car. They are a commodity in their own right. They last for much longer, and you kind of maybe buy your car and pay for a battery just like you would pay for fuel right now. Who wants to jump in on that?
Yeah. Okay, if
Stephen?
you allow me, please.
Oh, yeah, sorry. Waseem, you want to come in?
Okay.
Yeah.
Okay. So, see, this is a very big uh, dilemma. The point is that right now, if you go and buy an electric vehicle, and the battery of the vehicle is, as I told you, that it's 80% of cost of the vehicle itself. When you take this vehicle to secondary market, there is nobody to evaluate the life of the battery, and secondary market takes that as a dead battery, or much more lower than whatever the life of the battery is left. That is the reason the batteries should be capitalized separately, and the owner of the vehicle should be the owner of the vehicle itself. We are working on this project as well. We are developing a full technology that in which one company can supply a battery of a vehicle, which can be charged on the usage basis. There should be a tariff. We are developing a software uh, that can that can charge different tariff rates according to the usage. If somebody is using abnormally on very high temperatures and very high sea rates, there should be a different tariff than if somebody is using a battery as a standby mode. So all of these are all evolutions, and I think the time will come when these things will come up, and we will have apps on the phone where battery will be managed separately and capitalized separately, and vehicle will be done separately, and it will be a much easier life for a vehicle owner to own a vehicle, electric vehicle as well.
Stephen, did
Let
you want
me
to jump
let me
in? Oh,
also
Celina, go ahead.
yeah
Sorry.
let me also comment. Um, I think people have been looking at battery swaps for a while. There's been a number of notable entrants, and there's some folks doing it right now. It tends to be very effective if your batteries can't charge quickly, right? Uh, if you can actually charge the battery quickly, swapping is more work, a lot more work, right? What you have to do with a swap station, right? You have to have all the capability to pull the battery out of a car. And right now, when you look at you know EVs, the battery is a big chunk of that frame, right? So it's a substantial piece of hardware that you've got to pull out of the car, and then you have to manage the inventory in your swap station. You have to charge those batteries. You have to have them going back out to other cars. It's actually quite a bit of logistics. It's a lot easier to just charge batteries, right?
Mm.
So if you can get the charge times down, swapping becomes actually less interesting. That's one of the things that we think at QuantumScape that's the real promise of solid state, that we think you can get really high charge rates and really high energy density, which is difficult. That's something that's the holy grail, right? And that's why we're excited about the technology, because it gives you that possibility. And a lot of things become simpler when your charge times are 15 minutes or something, or ultimately you want even lower than that, but even a 15-minute charge time starts looking really appealing.
Stephen, we have two slightly contrasting views there. Celina thinking that swapping batteries is less likely once you have, solid state really as a viable technology. How do you think it affects kind of the business models around batteries that we
Well,
currently
I
see?
think we'll see battery swapping first in the lithium market if we see it at all. So if it's successful there, perhaps then we'll move into solid state, which, as you say, it could be better or worse in that market. But I think lithium market will lead that innovation. I think the one thing to say about solid state is, at the moment, even though the potential is for much longer life and faster charging, etc., it's not there yet. Poor cycle life is one of the major drawbacks of solid state. So that would potentially affect, the battery swap business model. And it's one of the things that at the Faraday Institution, where we're focusing our research, we're more in the academic, the basic research at the earlier stage of commercialization. So trying to solve the fundamental challenges of the chemistry. In our, for example, our Solbat project, which is run by University of Oxford, who've been working on solid state at the fundamental level for the past 2 or 3 years, and now we're moving into commercialization, developing a consortium around that. So I think there's still a lot of things that need to be solved before you get into the battery swap model.
But can
I've
I
got
just
quite a few
add on
questions. Sorry, go ahead.
I believe, I think what Celina said is about right. I mean, I think if you do get the fast charging, there's no need for battery swapping. I think I totally agree with that. And there are technologies out there that can do super fast charging, particularly if you have a smaller battery with shorter. If you don't need long range, if you don't need the 500 kilometers range, then you don't need such high energy density. You can go for a smaller, lighter battery, cheaper, that you can charge in 5 or 6 minutes. That is also a viable alternative. That's something that, for example, Nibalt is working on out of Cambridge. So there are different ways of doing this, but I think the battery swapping is not really a great solution if you can do fast charging.
Lots of questions to get through here. I will ask one of the controversial ones first. Owing to its promise, should solid-state research be made public, like the Volvo seatbelts, etc., or COVID vaccines? I suppose the question is really, would this technology be viable faster if there was some sharing of, I guess, IP and of research? Who wants to jump in on that? Celina, perhaps we'll start with you. You're smiling.
Sure. Yeah, in the U.S., we use the capital markets as a way to fund work and fund expansion. So that tends to mean that you hold on to your IP, but it's actually more than that. You know, we have patents, we have IP, but a lot of this is know-how as well, and it just takes work to take that. You know, you have a great idea, right? But actually figuring out how to do this every day with high efficiency, with high yield, that's that's a lot of know-how that it doesn't transfer like you would think. It's not like, oh, here's the magic formula and now everyone can do this thing. That is not how it works. It tends to be, you know, well, you know, these are the materials, and then here's how you put them together, and here's all the details of the equipment for doing that, and here's all the quality processes that have to go along with it. It's it's a huge body of knowledge. It's not one thing.
Waseem, do you agree?
So yeah, I do agree. As it's a lot of knowledge base, which especially it's not only the material science, then how you process that, and after that, how you electronically control that, and all of those things. And it takes a lot of research and a lot of time and a lot of man hours to get to those things, and cannot be very easily. Well, we are running commercial projects, so we need to hold IPs as well, so that the project becomes commercialized properly till the time IP goes out in the market. But I'm sure as all other technologies came up, all other IPs they came up with time. This will happen as well. Slowly, things will move in the market. But right now we are on a very early stage where the products are not even introduced in the market. So at this stage, probably everybody will try to hold the IP to get to achieve whatever commercial companies want to achieve.
Yes.
Yeah,
Questions
I think
on...
it's
Sorry,
not
go on.
really. It's not really an either-or answer to that. I think it depends on where you are on commercialization. So at the early stage, and if you're dealing with the uh, academic sector, which we are in Faraday, then a lot of the work at the basic end is published in academic periodicals. But as you get into the commercialization phase, I think there is a need for the IP to be protected, so that you create incentives for people to invest in the industry and undertake this high risk research, because the rewards are high as well. So you need a little bit of both, a mixed model.
Yes.
Yeah.
Only a couple of minutes left. Sorry, did someone want to jump in there? Oh, no, I thought I heard someone. Only a couple of minutes left, and some of these questions are about some very hard numbers that people want, and I thought we might as well leave people with some concrete projections, if anyone has any. And the two questions then that relate to this are: I've heard that solid-state supercapacitors have a high energy density and a charge time of 6 minutes. Is that true? And someone else wants to know, what is the forecast cost for solid-state batteries by 2030 in dollars per kilowatt hour? So I don't expect everyone to necessarily have an absolutely perfect prediction, but who wants to give us some idea of how quick the charging time could be for, say, an EV? I'm assuming the 6 minutes is relating to charging an EV, and a price per kilowatt hour. Maybe, well, Celina, you're smiling, so let's start with you.
Well, I'm not going to jump in on Waseem's party. I think he could tell us about supercaps. With the forecast cost in dollars per kilowatt hour, there's the battery industry. It's been like energy increasing and cost decreasing over the last 10 years, but it tends to go in small percentages. Right now, though, I think we're starting to see the first time that the dollars per kilowatt hour for batteries are going up. Right? Everyone's been targeting sub $100 per kilowatt hour for quite some time, but I think the last numbers I saw that the prices were going up, first time ever, and that's being driven by raw materials costs, okay, BOM cost, and I think saying what the technology could cost right now, just based on the technology and based on a situation where the supply chain was able to supply the raw materials at increasingly better efficiency. It's not a good idea right now, because right now we need to bring new raw material sources online, that's a large capital cost in and of itself, and it takes time. If you talk to people about how long does it take to bring a nickel mine online, they'll tell you somewhere between 5 to 10 years, right? So if you're going to increase the supply of raw materials, my personal feeling is we're in for a squeeze for a while, and battery cell costs are going to go up. That's where I look.
I think it's
a
probably
necessary
the
reality
case.
check there. We are
I think
completely out of time.
probably,
Just
yeah.
very, very quickly, Waseem, on the charging time,
Yeah.
in one sentence,
Yeah.
6 minutes,
Yes.
doable?
So we have achieved the C rate of 50 C, and we can definitely do 6 minutes very easily. We have tested, and as I told you, we our cells can take 50 C as well. So we can achieve in few seconds as well.
Marvelous. Well, so many more questions to get through, but as always the case with interesting discussions, we've run out of time. So only remains for me to thank my panel, Stephen, Celina, Mark, Waseem. Thank you for your time today. Thank you all for your questions, and please do stay tuned. Next up, we have our keynote interview with Ashwani Gupta, the Chief Operating Officer of Nissan, on building a future-proof EV ecosystem. Thank you all.
Thanks.
Thank you.
Thanks.